This lesson is very hands-on. I'm going to provide you with a development environment and all of the project files needed to implement GitOps workflows using ArgoCD with Kubernetes. We're going to look at three different approaches. First, we're going to set up an ArgoCD application resource that points directly to our GitHub repository. You'll see how ArgoCD continuously monitors our Git repo and automatically applies any changes to our application running in Kubernetes. So our Git repository essentially acts as this single source of truth, affecting everything that happens in our Kubernetes cluster. Next, we're going to scale this implementation using Kustomize. So once again, with Kustomize, we maintain this single source of truth where we've got a base configuration for the ArgoCD resource, as well as development staging and production overlays. And these overlays, depending on how they've been configured for each environment, will essentially customize how our base configuration treats changes to the Git repository and how it will apply them differently for development, staging, and production environments. Next, we're going to explore how ArgoCD handles Helm charts. So instead of raw Kubernetes YAML files, our Git repo is going to store a Helm chart. You'll see how ArgoCD can deploy these Helm charts to Kubernetes and automatically detect and apply any changes that is made to the Helm chart values.yaml file, keeping our application in sync with whatever desired state we want in our Kubernetes cluster. So as I mentioned, this tutorial is completely hands-on. I'm going to provide you with a pre-configured environment and all of the project files. Now, this is just one of many hands-on DevOps tutorials that I offer, so if you find this valuable, hit subscribe for more, and now let's dive in. The first thing I want you to do is go to this GitHub repo. I left you a link to it inside of the video description. Okay, once you're there, this GitHub repo allows us to deploy a particular application using three different GitOps workflows. The one we just talked about, the basic one, the one with Kustomize, and the one that allows us to deploy Helm charts and continuously monitor any updates made to them. So this GitHub repo is essentially going to be our single source of truth, whereby any changes made to it will be detected by our ArgoCD application resources that we're going to set up in our Kubernetes cluster. So first and foremost, I want to point you to the fact that this repo is needed to follow along with this current YouTube tutorial that you're watching right now, but this tutorial is also available as a written article. So if you're the type that prefers to read, feel free to click on the link here. Anyways, I'm more the type that prefers to watch, but that's up to you. Let's go ahead and clone this repo inside a directory of your choice. So I'm going to clone it inside of a directory I called YouTube tutorial, and then simply launch it inside Visual Studio Code. Let's make some magic. We'll go ahead and spin up a new terminal session, and let's begin. So first things first, there are clear prerequisites in order to follow the tutorial. If you don't meet one of the prerequisites, please go to the link that's next to it. Once you do, we're going to install ArgoCD on our cluster using these 4 commands I prepared for you. If you're a Windows user, please make sure to copy these commands inside of git bash or whatever to get consistent results, the same results as me. So ultimately what this does is it adds the ArgoCD Helm repository to your local Helm configuration. Then it creates a namespace ArgoCD where we're going to deploy all the contents of our Helm release. And then afterwards, we're going to install an ArgoCD Helm release based on the ArgoCD Helm chart that is inside of the Argo Helm repo that we just downloaded. All right, so everything was set up. Our installation worked perfectly inside of the namespace ArgoCD. So let's make sure we've got all of our Argo artifacts up and running. So kubectl get pods -n ArgoCD. I can see all of my ArgoCD pods. Everything is running perfectly. And I left you with a bunch of other commands. Instead of copying this one, instead what I want to do is say kubectl get service. Let's get all the services that were deployed as a result of this Helm release inside of the namespace ArgoCD. Here we see the service ArgoCD server that can be accessed on port 80. So let's go ahead and say kubectl port forward will forward the service ArgoCD server, will forward its internal port 80 to a port on our host machine. In this case, I'll choose 8080. And then I'm going to put an ampersand so that this command always runs in the background, even when we stop the command to run other ones. All right, so I get an error from server, ArgoCD server not found. That's because it's inside of the namespace ArgoCD and I did not specify that. So here I'm going to say dash namespace ArgoCD. Try that again. Beautiful. So now if I go to localhost 8080, now we need to log in to the ArgoCD UI. So the username is admin because I did check the documentation and looked inside of the Helm repo. That's the username. I left you a command that you can use to retrieve the credentials. Again, Windows users run these commands inside of git bash. So basically all this does is it grabs the password from the ArgoCD secret and base64 decodes it into plain text just to make sure that you have this secret inside of your ArgoCD namespace and it wasn't renamed for whatever reason. Maybe you're watching this in the future. Say kubectl get secret -n ArgoCD. Ensure that that's the secret name. If it's not, adjust it. But in this case, the secret name is consistent with what I have in the command I gave you. We can extract the password from that secret. So I have a percent sign here. Please don't copy that into your password. Only copy the plain text itself that was given back. So I'm going to copy it here for reference. Obviously, yours is going to be different. So copy the password over here, sign in. Beautiful. So this is the UI that we're going to use to create all of our ArgoCD applications, which will ultimately connect to our Git repository as our single source of truth. So ultimately, what we've got is, let me go to my repo. We've got an application, a Great Submission API, which consists of a deployment as well as a service. A deployment for our pods and a service where we can access these pods. And what we want is to have ArgoCD detect these Kubernetes manifests and automatically deploy them itself to the Kubernetes cluster. The advantage behind that is, if changes are ever made to these manifests, ArgoCD will be able to automatically deploy them, track these changes, and synchronize them with our Kubernetes cluster. Okay, so let me just start by introducing the first basic GitOps workflow. So here we have a custom resource, a custom ArgoCD resource known as an application. The purpose of an ArgoCD application is to connect to some repository. Okay, in this case, the repository is the one I initially gave you in the beginning of this video. It's going to connect to some repository and it's going to track any changes made at the head. What head means is the latest commit on the default main branch. So if any commits are made on the default branch, Argo is going to be able to track these commits, make sure there isn't a drift between the desired state that's in the Git repo and the current state in the Kubernetes cluster. And if there is a drift, it will reconcile that difference by applying all the necessary changes, okay? And here we specify the path where it should look for resources to deploy. So here we're telling it inside of this Git repo, monitor the resources inside of GitOps/basic. So now it knows to deploy these resources and continuously monitor them for any changes that may happen. The sync policy is really cool because you can control how the synchronization process happens. So prune, if you hover over it, specifies whether to delete resource from the cluster that are not found in the sources anymore. So whatever is not found in this source anymore, prune ensures to delete it. Self-heal, again, very self-explanatory, specifies whether to revert resources back to their desired state if there's a drift between what's inside of the Git repo and what's currently in Kubernetes. And this one is really cool because it creates the namespace where we intend on our resources being deployed in the Kubernetes cluster. So here we're saying deploy everything from GitOps Basic into the default Kubernetes cluster that Argo is currently running inside of the namespace grade demo. If that namespace doesn't already exist where we want all of our resources to be deployed, it will create the namespace automatically. All right, so that's enough talk. Let's go ahead and apply all this and see it in action. So let me clear the output right now. Say kubectl apply -f argocd/applications/basic application.yaml. And now if we go to the Argo UI right over here, we see that the ArgoCD app named Great Submission was just deployed. All right, pointing to the repository that we want it to point to. And it was able to deploy the Great Submission API service, as well as the Great Submission API deployment that it found in /GitOps/basic. It deployed everything that we pointed it to inside of the source. And that's pretty cool. So this is the basic GitOps workflow, where we simply connect an Argo CD app to a Git repo. Nothing more, nothing less. What's really cool is that now we can go to Kubernetes and make sure that they were actually deployed. So everything so we know everything was deployed inside of the namespace grade demo. So kubectl, let's get the deployment that was deployed inside of grade demo. There you go. That's the deployment right over here. Great Submission API deployment containing 3 pods. Great Submission API deployment containing 3 pods. Beautiful. We'll say kubectl get service -n grade demo. And we've got the service as well that's been deployed. The service is a node port, so it exposes a port on our node, on our local machine in this case, port 31,000, where we can access the Great Submission API. So might as well try it, whatever. So great, localhost 31,000. Beautiful. The Great Submission API just sends us back an empty response. If we say /grades, we get an empty list of grades because we haven't submitted any grades yet. Anyway, all that is to say that everything is working. Now, what's really cool is that any changes that we make to this Git repo, we can synchronize using Argo, and it's going to automatically make changes in our Kubernetes cluster based on our single source of truth, based on whatever we have in the repo. Now, obviously, you can't make any changes to my repo right over here because you don't have the access rights. So what I'm going to do to mimic what it is that you would need to do in order to visualize Argo CD in action is let me just open another window. All right, so this is another GitHub account that I have, rslim087b. I know, not very creative. Let me go ahead and go to this Git repo, which was created by rslim087a. And I'm going to fork this repo, which is what you should be doing as well. So fork allows you to create your own copy of this repo that you can do whatever it is the heck that you want to do with it. In this case, whatever we do in this tutorial. Okay, and now upon forking it, what you want to do is now point your Argo CD application to track changes made to this Git repo, not rslim087a. So if you're using VS Code like me, what you can do is press Command-Shift-F or Control-Shift-F for Windows. Look up wherever it says rslim087a. Replace that with rslim08 or whatever your username is because you just forked it, right? Replace all occurrences. So now it points to this new GitHub repo that we're going to mess around with to our heart's content. So let's clear the output. I'm going to delete the application we currently have. So kubectl delete the Argo CD app that is in the namespace Argo CD. So the app is called Great Submission. That is in the namespace Argo CD. That's been deleted. Okay, beautiful. Now let's go ahead and reapply it because now it points to our new Git repo. kubectl apply -f argocd/applications/basic application.yaml. If we go back here, this doesn't exist anymore. Go back to applications. Now we have a new Great Submission app pointing to this new Git repo, and everything worked beautifully. Now, let me close the window where you have rslim087a's Git repo open. Go to yours, because that's where you're going to be making changes. Go to the source that ArgoCD is tracking, go to the deployment, and make changes to it. So instead of 3 pod replicas, put 5, okay? And now when I press sync, ArgoCD is going to recognize that it's out of sync with what we have currently, and it's going to ensure that we have 5 pod replicas instead of 3. It's going to reconcile the difference by applying the new updates. There you go, out of sync, now it's back in sync. Created 2 new pods. Beautiful, a single source of truth that dictates everything that happens in our cluster. And we can do that through ArgoCD. So that was a very basic ArgoCD workflow that you just witnessed. The next GitOps workflow we're going to look at is how we can customize the ArgoCD deployment using the customization tool. Okay, so this ArgoCD application pretty much does the same thing as this one, all right? There isn't much of a difference. You'll notice the files are actually pretty identical. But instead of pointing, so this one here points to the base configuration that contains all of our manifests. This one, what it does instead is it points to an overlay. The overlay, what it's going to do is it's going to customize the base configuration depending on what kind of environment we're deploying our resources in, whether that's a dev environment, a staging environment, or a prod environment. In this case, we're pointing to the path customize/overlays/dev. What's in there? Let's find out. So we'll go to customize/overlays/dev. Now, ArgoCD, when it sees a customization.yaml file in whatever directory you point it to, it knows to automatically go there. Customization basically steers ArgoCD and tells it where to go from hop to hop. So this is the first hop. The first hop is telling, hey, ArgoCD, all the resources you're looking to deploy, they're inside of a base folder that go 2 folders back. So if we go 2 folders back, it's telling Argo, hey, go to this base folder. That's where your resources are. But before you do, whatever resources are inside of this base folder that you're going to deploy, give them a prefix of dev. So this time when it deploys the deployment and the service, they're going to be deployed as dev Great Submission API. All right, so that's one way that we've customized the deployment using our customization.yaml file. And there's another thing it's doing is it's going to patch a particular Kubernetes resource, okay? Specifically the deployment named Great Submission API. So Argo is going to look for this replicas patch.yaml, and it's going to see, so here you're seeing not the full deployment, you're just seeing the portion that we want to patch. So once Argo sees this resource, it will apply this patch, and ultimately all that will change is the number of pod replicas. So bearing these considerations in mind, the fact that a patch needs to be applied to some deployment, the fact that a name prefix needs to be given to every resource inside of the base folder, now it goes to the base folder. Okay, that's 2 directories back. So we go to customize, go to base, and again, as I told you, the customization.yaml pretty much steers Argo in the right direction, what it needs to do from hop to hop. Now we're at the second hop. Okay, and the second hop goes, hey Argo, just go ahead and deploy these files. So Argo is now going to deploy these files bearing whatever considerations we had in mind inside of the overlay, and it's going to effectively patch our Great Submission API deployment such that this will only have 1 pod replica. And you'll remember the first customization told it to give each thing inside of the base folder the prefix dev. So let's go ahead and visualize all this. So kubectl apply-f customize application.yaml, or sorry, argocd/applications/customize application.yaml. Go to here. So now we've got two Argo applications, the one that implemented the basic GitOps workflow and this Great Submission Dev Argo application that used Kustomize in order to customize the deployment such that every single artifact that was deployed in base was given the prefix dev, courtesy of our dev overlay, and the deployment itself was modified to only have a single pod replica. So in the base deployment, it originally had 3, but because the patch was applied, a single pod replica is deployed. So now, what if I change this to 5? Commit the changes. Again, what's going to happen when I press sync is our Argo app is going to start at the first hop, overlays/dev. It's going to go to this customization. It's going to know, oh, the next hop I need to go to find the resources is this one. But before I do, I need to bear these considerations in mind, the fact that I need to apply a dev prefix and the fact that I need to apply a particular patch to whatever deployment is called Great Submission API at this hop. So then it goes to base, to the next customization.yaml. This tells it what it needs to deploy. And Argo already has all of these considerations in mind from the previous customization.yaml, which effectively customized the deployment and patched it to now have 5 Great Submission API pod replicas. All right, so that's it for that. And now what's beautiful is what I can do is duplicate this. All right, let me just copy paste. We'll call this customize application prod. Now, wherever it says dev, I'm going to change it to prod because now ultimately it's going to connect to another customization.yaml file, but it's going to start from a different starting point. So now the first hop is at overlays/prod. This customization.yaml pretty much does the same thing. The resources, it's telling it it's 2 directories back and then to base. Whatever resources you deploy in base, give them this prefix and make sure to apply this patch if you find a deployment called Great Submission API. What that patch does is it ensures that the Great Submission API deployment, upon it being deployed, is given 3 pod replicas. Let's change this to 7 because now we're in prod, right? So we'll commit the changes. And so that's going to lead it to base, going to the next hop, which tells it which resources it needs to deploy. It's going to deploy them, bearing the considerations from the previous customization.yaml file. So now let's go ahead and say clear kubectl apply -f customize application prod. So sorry, ArgoCD/applications customize application prod.yaml. Beautiful. So now we've got 3 Argo apps. One that deploys them for a prod environment and one that deploys them for a dev environment. So the dev overlay ensures the deployment is done with 5 pods because apparently that's what's needed for a dev environment, and the prod deploys them with 7. Okay, so it's pretty cool how we can go from one deployment to another by simply changing the overlay. So this approach is what is typically used in enterprise environments, pointing to overlays and modifying each overlay to perform your deployments based on whatever specifications are needed for different environments, whether that's prod, whether that's dev, whether that's staging, okay? Now, the final GitOps workflow I want to point you to is this one. So this is another ArgoCD application resource, but what this does, again, same thing, is we're connecting to the same Git repo, but the path now points to Helm/Great Submission. So what's inside of Helm/Great Submission? Let's go there. That's a Helm chart. So if you're not familiar with what a Helm chart is, highly recommend you check out my Kubernetes course. Actually, if you're not familiar with what a Helm chart is, link is right over here. The purpose of a Helm chart is not all applications can be deployed using a simple deployment and service manifest. Applications can get really, really complex, and all of their configuration files, instead of deploying them very loosely, we can deploy them as a single package inside of a Helm chart. Okay, every Helm chart has templates where all of these configuration files are packaged into, and a values.yaml file that we can use to steer the deployment of that Helm chart. Now, Argo, the beautiful thing about Argo is it has native support for Helm. So you can just tell it, hey, at this path, you're going to see a Helm chart. And the values file for that Helm chart is values.yaml. And we can effectively use this to deploy our Helm chart very, very easily. And it's going to deploy it in the namespace grade Helm demo, automatically creating that namespace. So we'll go ahead and clear the output and we'll say kubectl apply -f Helm, sorry, ArgoCD slash applications slash Helm application.yaml. Creates another Argo app. What that's going to do is deploy our Helm chart. It's going to deploy the Helm release. And what was released, once again, was a simple deployment and a service, the deployment containing 2 pods, okay? Pretty cool that we can automatically deploy Helm charts using Argo. Now, Argo is consistently tracking any changes made to this path inside of this Git repo. And remember that we can use the values.yaml file to steer the deployment and upgrade of a Helm chart, of a Helm release. So here, if I change the replica count from 2 to 4, upon synchronizing, Argo is going to recognize these changes and upgrade the Helm chart. Upon upgrading the Helm chart, the Helm release is now going to release a deployment with 4 pods. And that's all she wrote. I really hope you enjoyed this tutorial. In this tutorial, you learned how to deploy an application using 3 separate GitOps workflows. If you enjoyed this, highly recommend you subscribe for more hands-on DevOps tutorials like this. And that's pretty much it. See you in the next one.